Till now we have seen three methods to solve simultaneous linear equation in two variables. First one is elimination method, second is graphical method, and third one was Cramer's rule, or we can see it as determinant method also. Now for that we have seen standard form of linear equation in two variables, and we have found a solution of the simultaneous equation using those three methods. Now we are going to find solution of simultaneous equation which are not in the standard form of linear equation. So what is the standard form of linear equation? Ax plus by is equal to c. This we have already seen it, where a and b are not 0, they cannot be 0, and c can be 0, it is a real number. Now why a and b cannot be 0? Because if a becomes 0, then what will be the equation? By is equal to c only. And is this the linear equation in two variables? No. Again, if b is 0, then what will happen? Only ax is equal to c. And even this equation is not in two variables. So that is why this condition is necessary for the standard form of linear equation in two variables, that ax plus by is equal to c is the standard form, where a and b cannot be 0. So remember this standard form of linear equation in two variables. Now in practice set 1.4, the equations are not in the standard form as I said. So let us see one solved example what is given. This is the equation, first equation. 4 upon x plus 5 upon y is equal to 7. Now as you can see, how many variables are there in this equation? 2. 2 variables. But is it the standard form? No. Because x is in denominator here, y also works here as a denominator. We need x and y both as the numerator function, but here they both are denominators. So this is not the standard form, not a standard form. So before finding the solution of this equation, with it another equation is given to you. This is your equation 1. We have to convert this thing into the standard form. Now how to do this? Let us see it. This is your first equation and first equation. We will consider this equation first. And your second equation is 3 upon x plus 4 upon y is equal to 5. Even this is not of the standard form of linear equation in two variables. There are two variables, but here x and y works as denominator, not as numerator. So now to convert this both equation into the standard form, and then we will find the solution of those two equations, and that will be the solution of this equation number 1 and 2. Now how to do this? Now what is the common thing you see here? Both x and y works as a denominator. So how to convert them? See here properly. What is the common thing? Consider this first equation. If I write 4 as here, multiplied by 1 upon x. It is same as 4 upon x. Because 4 ones are 4, it is again 4 upon x. Same, I have not changed anything. Again same here. 5 into 1 upon y. Same as 5 upon y, I have not changed anything. Plus here as it is equal to as it is 7 as it is. Same goes for second equation. I am just writing it in a different way. What it is? 3 into 1 upon x. It is same as 3 upon x. Plus as it is 4 into 1 upon y is equal to 5. This is your equation number 1 only and 2 itself. Now what is the common thing you see? 1 upon x, 1 upon x, 1 upon y, 1 upon y. Now substitute something on the hand of 1 upon x and 1 upon y, so that you can convert these equations into the standard form of linear equation in two variables. Now how to do this? Put 1 upon x as capital X. See the difference between my small x and capital X. And 1 upon y as capital Y. What will be the form of equation now? See, consider first equation. We are putting 1 upon x as capital X. So 4 remains as it is. Into capital X. Because 1 upon x becomes capital X. So capital X as it is. plus as it is, 5 as it is, 1 upon y put as capital Y. So it becomes 5 capital Y is equal to 7. This becomes your equation number 3. Same goes for second equation. 3 into 1 upon x. 1 upon x is capital X. So it becomes 3x plus 4 into 1 upon y. 1 upon y is capital Y. So it becomes 4 capital Y, 5 as it is. Equation number 4. Now you will see that these both equations are in the standard form of linear equation of two variables. Ax plus by is equal to c, where a is 4, b is 5, c is 7. Again ax plus by is equal to c, a is 3, b is 4 and c is 5. In this way you have converted these two equations into the standard form. Now you will solve this 3 and 4 equation by using any method, either elimination method or graphical or Cramer's rule, and you will find the solution of this equation. Now I am going to do the same. So let us go for these equations. I am working this out. I am solving this by using elimination method. 4x plus 5y, write it one below the other as usual, as we have seen in this in elimination method, and 5. Now no coefficient is same, neither 4, 3, 5, 4. So what we will do, multiply this equation by 3 and this equation by 4. This equation by 3 and third equation, fourth equation by 3 and this equation by 4. What we will get? 3 by 3. 3 4s are 12. 3 5s are 15. 3 7s are 21. I have skipped out one step. We write it as 3 into 4x plus 5y is equal to 3 into 7. I have told you to write this step. Even you are going to write it. But for now I have skipped it out. Don't forget to write it while writing it in your notebook. Next, so this will become your equation number 5. Even if you don't name this equation, no need. 4 into 3, 12x plus 4 into 4, 16y, 4 into 5, 20. Now solve this two equation. The same solution will be of this third and fourth. So no need to name this equation for me. I guess it will be okay. Again 12 and 12, coefficient of x is same, but the sign is also same, so we are going to subtract the equation. So this becomes, this gets cancelled, minus minus. 15 minus 60 is minus y, greater number is 16. 21 minus 20 is 1 itself. Minus y is equal to 1 gives you y is equal to minus 1. Minus sign is shifted on the right hand side. So this is the value of capital Y, not small y. It is the value of capital Y. Now put this value y is equal to minus 1 either in 3 or in 4. You will get capital X. As usual, it is same as elimination method. Nothing different. Don't think about first two equations for now. Just think about equation number 3 and 4, your converted equations. And you are finding the value of capital X and capital Y because these are the roots of this equation, not small x and small y. So what is your capital X now? Put y is equal to I am putting this in equation number 3. So it becomes 4x plus 5y. I am writing the value of y. It is minus 1, so I am giving bracket 2 is equal to 7. What will be the answer? 4x minus 5 of course is equal to 7. 4x is equal to minus 5 will be shifted there. 7 plus 5, it becomes 4x is equal to 12. 7 plus 5, x is equal to, it becomes 12 divided by 4, and so x is 3. So these are the roots of your equation number 3 and 4. Capital X stands for 3, y stands for minus 1. Now what about the roots of main equation? That is your equation number 1 and 2. What we have done, remember the values of capital X and capital Y. Y is minus 1. What we have done? 1 upon x as capital X. So put this value of capital X 3 in this equation. So what you will get, 1 upon x is equal to 3. Now 3 stands here for numerator. Nothing is there in denominator, implies it is 1. So cross multiplication, what you will get, 1 is equal to 3x. That is small x is equal to 1 upon 3. 3 is shifted in denominator because here it is multiplying by x. So shifting it on left hand side, divides by 3. So your small x is 1 upon 3. This is your the value of equation 1 and 2. One of the root of equation 1 and 2. Again 1 upon small y was capital Y, and your capital Y is minus 1. So put capital Y as minus 1. Same thing applies here. Y will be shifted here, cross multiplication. So what you will get, 1 upon minus 1 is small y. That is 1 upon minus 1 implies minus 1. So y, small y is minus 1. So this is the value of x, root of equation number 1 and 2. Second root of equation 1 and 2 is y is equal to minus 1. These are the real roots of your equation number 1 and 2. In this way, you are going to solve such equations which are not given in the standard form. You are going to convert them into the standard form by using these steps. And then you are going to find first of all the value of capital X and capital Y. And then you are going to find the value of small x and small y. These are the roots of your equation. This was the solved example from your textbook, page number 17. Now you are going to solve first example of practice set 1.4, which is same thing, same equation given as the solved example of your textbook, just the numbers are changed. So practice set 1.4, first question as homework.